But this room here is going to be the non-paper session on debates. We have two debates that we've organized for you today. The first debate is, sorry, let me just remember exactly what the... So the first debate is going to be so Ayush Mishra from NUS, who will be, and Aditya Philip from CMU, who will be debating the role of deployability thresholds in congestion control on the internet. Yes, please come. Yeah. So I want to clarify before we start that this is not intended to be an adversarial debate. We will not be picking a winner or anything at the end. This is for us all to learn. If it helps, you can think of it as sort of a panel discussion with two people, and we'll try to go a little bit more in depth into the topic that we're talking about, which is in this case deployability thresholds for congestion control algorithms, rather than trying to cover a large variety of topics across things. So which one of you is going first? Do we decide? Okay, so we'll have Philip from, I introduced you, right? Yes, yeah. We'll have Philip go first, and he'll start with a 3-minute opening statement, and we'll have Ayush give a 3-minute opening statement. This is not going to be timed super aggressively or anything, but then this is just sort of to establish some like base upon which we can discuss, and then we'll sort of go from there. I want to be very clear that audience participation, if you want to call it cross-examination, you can do that, but audience participation is strongly encouraged. Please come ask questions, and I'll be moderating the discussion and making sure that we stay both on topic as well as answering or responding to any audience questions that we might have. Okay, great. So I'll let Philip start.
Hi everyone, great to have you here. To start off, just to specify the scope of what we are discussing, really, we're kind of focusing on, so I guess the big question now is you have CCAs like BBR being deployed. And CCAs like BBR do give you performance gains, but people have found that this comes at the cost of fairness. Fairness itself today has many meanings. There's a lot of work that talks about throughput fairness. There's also the question of latency fairness, where you make sure you're safe to delay sensitive applications and so on and so forth. So the question we're really trying to discuss today is if and when we do decide on a deployability threshold, which does seem more and more important today, and there's also interest from the industry in having potentially a deployability threshold with the IETF congestion control working group. Reaching out and actually having industry collaborators to settle on a threshold for deployability for new CCAs. So at that point, the question is, what do we as a community think is a good threshold for deployability? And most likely, this threshold needs a combination of performance and also fairness. It's not like one is completely more important than the other. And what we'll be discussing in the debate today is Ayush's going to be arguing for the performance side of things, where a threshold for deployability should be more focused on how much performance improvements CCA can give you. And I will be arguing for the fairness side of things, so that while performance is important, we should be very careful about deploying unfair CCAs to the internet today. And with that, so with that, I'll start speaking for fairness. So now, fairness isn't just about making sure large corporations like Google and Netflix get their fair share of throughput on the internet. It's actually also a very fundamental part of how we view the usability of the internet. So, for example, no one here would probably want to have a video conferencing call where every time you have an important video call, you go to all your roommates in your house and tell them, hey, make sure you don't watch anything on the internet. Make sure you turn off your Android and Windows devices in case there's an update that happens. And that would definitely be not the multiplexed way the internet was designed to be used. That's clearly a bad outcome for everyone, not just corporations, but also us. So that's one aspect of it. And the second is, we're kind of at this time in the internet where we're seeing a new wave of services with a different set of requirements. So once upon a time, the internet was just about downloads. Then we got things like video services and video conferencing. And now you have new services like cloud gaming and AR/VR streaming. And the feasibility of, or rather the first impressions we have of these services, which require both high throughput and low delay because they're real time, is going to be determined largely by how fair the internet is today. If these new companies come out with new cloud gaming services and we all try them, once initially, we see really bad resolution, we see really bad latency when we try moving characters around, and we decide, oh, cloud gaming sucks. It's never going to take off. And that can completely kill individual industries. We would not be using Zoom or Google Meet or even having virtual meetings as much as we do today if when we first tried using it during the pandemic, it was just horrible and kept dropping all the time. So fairness does play an important role in determining what services we will use and the evolution of the internet itself. Now, the second thing about why I advise for caution when it comes to fairness is that so performance, you can kind of always A/B test it. So these large corporations, what they do is, of course, every time anyone designs a CCA, you test it in a bunch of different network settings for performance. But in practice, what you do is you deploy it on the internet and you A/B test it. You say, oh, for example, Dropbox tomorrow says, I'm going to double, I use BBR, I'm going to double the BBR's bandwidth probe. And they see, oh, okay, we get a little more performance in the A/B test compared to earlier. And they see, okay, maybe latency went up a little, but they got a lot of performance. The catch here is that when you're A/B testing and seeing performance improvements, you don't know if that's because of fairness loss. Put simply, fairness cannot be measured end-to-end and therefore cannot be A/B tested. So it's very hard to distinguish between, is the performance gain I'm seeing raw performance, or is it actually at the cost of fairness? And the issue with it coming at the cost of fairness is you can end up with this race to the bottom, so to speak. You can have Dropbox one day increasing the aggressiveness of their congestion control algorithm, and as a result, you end up with slightly higher latencies on the internet. And then Netflix a month later says, hey, for some reason our video quality has gone down. Maybe the internet has gotten worse. We need to increase the aggressiveness of our CCA. And then Netflix does this. And then you have a bunch of different companies doing this. And then 5 years later, there's a new SIGCOMM' paper which says, for some reason, over the last 5 years on the internet, latencies and loss rates have really been increasing. Who knows? And it's not easy for customers to figure out either. Maybe if it's in your house, you can correlate and figure out, oh, it's my roommate using the internet. But if congestion is just one hop away from you, you'll most likely just think, oh, Comcast sucks. They're not giving me the speed I paid for, or it's a very lossy network. So it has a lot of implications across the board. And lastly, fairness is also most likely going to be most important in low bandwidth networks where people are just getting onto the internet. And so these are emerging networks where people are still forming their opinions of what their favorite video conferencing service is. And you have to be very careful again, because if we say, hey, it's a free-for-all, there's a lot of incentive for companies to be extremely aggressive to grab these eyeballs from the get-go. And that is why I think fairness should be an important part of a deployability threshold.
Great. Thanks, Philip. So Philip thinks that we should care about fairness because it increases the amount of sort of what we can expect from the internet. It becomes more predictable. Ayush, I think you have a response for us?
Yeah. So hi, everyone. I'm Ayush, and I will basically be arguing the fact that maybe we should be caring more about performance than fairness on the internet. So I think one of the reasons fairness has come to the forefront in the recent years is because of the heterogeneity in the congestion control landscape on the internet, right? But I think what we fail to appreciate here is that this heterogeneity has not been created in a vacuum. The reason different people deploy different algorithms on the internet is because they have different goals, and they want to achieve these goals in different networks. I mean, we are beginning to appreciate this idea a little in the community, especially with proposals like RCS. But I still think that fairness sort of detracts a little bit from what our real goals should be for modern internet congestion control. And I think, in general, this is a sensitive topic to deal with because on the face of it, if you just consider fairness, it's a very virtuous thing to have on the internet, right? But I still think it's a metric that's living in a world where everyone just cares about throughput. So for example, we are having this debate between fairness and performance, right? Why are these two things on the opposing ends of the spectrum? Well, it's because subconsciously we think performance comes at the cost of fairness. We sort of think that, okay, performance has to be a zero-sum game because throughput is also a zero-sum game, right? But I think the reason fairness was a good goal in the past is not just because it promoted using the internet equitably for a long time, but also in a world where everyone cares about throughput equally and throughput gives you diminishing returns after a point, a fair allocation is the most efficient allocation that guarantees your optimal utility and quote-unquote a performant network. But on the modern internet, where performance does not just translate into throughput, but also delay and a variety of other factors, I feel like the optimal solution here can't really be captured by fairness, but other approaches like RCS that consider isolation. So, of course, how we achieve this isolation remains to be seen, because RCS is one of these first approaches, but I'm still on the fence whether we should be doing RCS on the internet. But I think we still do need to agree on the problem that we want to solve before we can look for the right solution. And finally, one thing I would like to say about fairness on the internet, especially given the fact that different people want different things and they're deploying different congestion control algorithms, even if we want to enforce fairness and deployability on the internet, from a practical standpoint, it's a very tough thing to achieve. So just how you can't judge a fish by its ability to climb a tree, it's sort of unfair to judge how well a throughput-sensitive congestion control algorithm is fair or deployable when it interacts with a delay-sensitive congestion control algorithm, for example. So in those scenarios, instead of looking at traditional ideas of fairness, you probably have to think of how we can achieve isolation between these contrasting goals and therefore have better coexistence on the internet.
Yeah, I think one point that Philip made that I don't think you responded to directly was this idea of the race to the bottom, right? Like, because we don't know the relationship, whether the gains that we're getting are because of more capacity was available, or because our congestion control algorithm was more efficient, or we were just simply being unfair, that this will eventually create this like race to the bottom, and this lead to congestion collapse eventually at some point. And maybe Philip will be writing this hypothetical SIGCOMM paper 5 years from now. But would you like to respond a little bit more directly to that point?
So I think the very reason the race to the bottom is happening is because of a lack of isolation. Right, so for example, I'll give an example. I'll give a concrete example of BBR, right? So we all like to criticize BBR a lot by saying that it's super unfair to cubic, but actually, if you look at the algorithm on the face of it, BBR is not an inherently unfair algorithm. The reason you get these unfairness results is because on the face of it, cubic and BBR are incompatible with each other. Right? So if you have a network that has only BBR flows, you're going to have a great network. It's going to have very low queues, but once you put cubic in, BBR is going to overestimate its RTTs and things are going to go haywire. So this is actually a concrete example where you sort of have this impression of having the race to the bottom, but you're having this issue because you have two competing ideologies or strategies that are not sufficiently isolated on the network. And that's because we still want to stick with ideas of fairness. We still, instead of thinking about isolation, we want to call out Google and punish BBR, right? But I really think going forward, what we need to look at more is isolation instead of fairness. Yeah.
Okay, so Ayush thinks that we should have isolation and that will save us. Do you have a response, Philip?
Yeah, and in some ways I do agree with Ayush with some caveats about having isolation on the internet. So for example, one of the things we found is that actually multi-flow services are prevalent on the internet. So we also have to think carefully about to what extent we can achieve isolation even if we had network participation. Most isolation schemes are flow level fair, and that's also what congestion control fairness is designed for. But maybe service level fairness in AQM is maybe something we should start looking at. That said, I don't want to go too much into that because even congestion control fairness is about flow level fairness. It's not like we're deciding for service level fairness from the get-go, even if we should be. Yeah, I guess the second note on that is that while I think having some isolation scheme like this would definitely be the best in the sense that, CC developers can finally focus on improving performance because that's what we set out to do. And let's be honest, fairness is hard. And it makes a complicated problem even more complicated. But the catch is, at the end of the day, I don't want a fair internet for my grandchildren, right? I want it right now. And from what we've seen, actual deployments that require in-network participation from ISPs have taken forever. I mean, look at IPv6 deployment. It's such a simple change. It doesn't introduce too much performance overhead, and it still takes forever. But on the other hand, most AQing schemes do require new hardware, and they are expensive for ISPs to not just replace this hardware, but the hardware they're introducing is itself expensive, and both in terms of energy and the actual hardware itself, because AQM is computationally a little bit more intensive than just pushing packets around. So I think maybe in the future, isolation would be a good goal to aim for. But in the present, until we have such AQM schemes on the internet, fairness should still be an important part of when we decide if we should deploy a CCA or not.
Okay. So isolation is too expensive, Ayush.
Yeah, so I think this is a great point, but I would also like to say that fairness is also, fairness or deployability is also a fairly hard thing to enforce. So again, I'll give the example of BBR, right? So if I'm a non-Google person in the industry and I view BBR's deployment, you know what I think is the worst thing that BBR did? It's not that they were unfair to Google. I think the worst thing they did was that they published BBR as a paper, because that exposed them to the research community, right? For example, Akamai has been deploying their proprietary variant for like 5-6 years now, but there is no research in the community because they didn't publish a paper about it. And if you did have a fairness or deployability standard for Akamai's congestion control variant, I would contest that it's harder to tell them to abide by your standard rather than coming up with some isolation approaches and then convince the ISP. Because in that case, at least the ISP has an incentive to implement isolation. But all your end hosts, like CDNs, they do not have the incentive to abide by your deployability standards. Yeah.
So going back to this idea that BBR should not have been published, what is the role of what should be published? If we should stop publishing congestion control algorithms because publishing them exposes us to criticism, then what are we all doing here?
No, so I think the issue is not that BBR was exposed to criticism, but I think the issue was that, okay, why was BBR criticized? It was criticized because most of the community still aligns with the idea of fairness. If we had an internet where we already had a notion for isolation, or we were able to isolate between different flows.
Sorry, that's not why BBR was...
Keith, can you go to the mic, please?
Sorry.
So we have a question from Keith.
That's not why BBR was criticized, question mark. That's my question. No, it wasn't criticized because the community believes in some ideology. It was criticized because what the paper says is not true. That's intellectually interesting. That these famous people who wrote this paper misled themselves. That's interesting, and it's interesting for us as a community to reason about how we evaluate claims intellectually in a paper. That's why the paper was criticized. Whether you subscribe to the ideology of whether or not flow rate fairness is a good idea or not, when you make claims in a paper, in this case a non-peer-reviewed paper in ACMQ, when you make claims in a paper and you make them very confidently and they're not true, that is worthy of scrutiny in an intellectual sense. Whether or not the objective function is one that is worth maximizing in the sense of a global communications network or not. That is why the BBR publication was criticized.
So I think there are two aspects that I think maybe we're perhaps conflating, right? The first is the point that Keith is making, that when you publish a paper, you're making like a scientific claim about whatever algorithm you're trying to do. The other is when you publish a paper, you're trying to convince people of some viewpoint, which in this case, Google is smart, BBR is the correct congestion control algorithm, et cetera. We should build consensus around that. This is the way of doing congestion control. I think the question that we seem to have here is, are these two things separate? Like, you seem to disagree there.
I mean, I do get Keith's point, but most papers that critique BBR critique it on the fact that it is unfair to loss-based flows, right?
Because the paper says that it is fair to loss-based flows, and those papers show that Google's paper was wrong.
But if it said that it is unfair to loss-based flows, would it still have been a problem?
Not in the same way. No, I think honesty would have been the better policy. I'm not saying that they were dishonest, but truth would have been more valuable in that case.
So does that mean we're okay with BBR being unfair on the internet as long as they mention that in the paper?
I think that's a totally separate question. I think when we speak as intellectuals, we would prefer for our papers to be the truth, and if they're not, we should learn why.
Okay, I mean, I personally think that the bigger issue is that, I mean, of course, Google can make their claims, but the bigger issue is actually what's happening on the internet, whether BBR is fair or not. Of course, since it's a non-peer-reviewed paper, I don't think we're taking the paper's claims at its face value. We run our experiments, and the issues that we critique are, of course, not the claims that they're making in the paper, but the unfairness that we see in our controlled experiments.
So to be clear, even if a paper is peer-reviewed, that doesn't mean we should take it at face value.
Yeah.
It got post-publication peer review by people who were in this room. It just didn't get pre-publication peer review.
Well, I guess just to, I do kind of agree with Ayush in the sense that a lot of flack that BBR got was for their fairness. I don't think if they published a version of the paper, they redacted it, said, sorry guys, we messed up, we didn't test it with multiple flows, and they published a version of the paper that said, we are unfair to Cubic, I think people in the community would still have an issue with it. And kind of an example of that was basically just when, for example, Ray's research came out, which showed that BBR was actually just going to take a constant fraction of the link, no matter how many Cubic or Reno flows it was competing with. Weiss ran this article which said, oh, BBR is being unfair on the internet, this is a big problem. And to their credit, the folks at Google were worried about this. They did not expect this behavior, and as soon as it came out, they started working on improving it, and they said that they had found some fixes in BBR v2. But I do think a lot of the narrative around BBR's, or the angst against BBR's deployment was due to its unfairness.
So, Philip, your point is that fairness de facto does matter because when fairness concerns were raised, they clearly affected the design of this deployed congestion control algorithm. But the congestion control algorithm was deployed before any of these fairness concerns were raised, right? So is there effective deployability criteria other than we wanted to do something?
Right. So I guess is that question more about like what can we do to
No, go ahead.
Yeah, what can we do to kind of set a threshold for deployability that corporations can adhere to if they just or was it something else? Sorry, could you?
Yeah, like what is an effective deployability criteria, or does there exist one? Like,
oh, right. That's a good question. I think an effective. So the good news on the internet is that. So I guess a full disclosure, we have been working on a fairness watchdog, and there's going to be a really great talk about it in the Singapore room in the next session. But the services owners we reached out to, Google, Netflix, etc., about any unfairness that we saw in the network. Luckily, they were very interested in what they could do to remediate this unfairness. So luckily for us, we're not necessarily working with adversaries. I think some of the things that limit them deciding what to do is, right now, we don't have a concrete test bed of deployability, where we just say, run your CCA on this, look at these fairness outcomes. This tells you can go ahead and deploy things on the internet. Because then at that point, I'm sure, like for example, Cubic is RTT unfair, right? But we still use Cubic. The question is, what is the standard set of settings we need to test in so people can know for a fact that this is okay, this is not. And I think as long as we have some uncertainty about what we as a community consider a good threshold for deployability, it's hard to get other people to sign on. Now to the second part of the question, which is what would a good threshold for deployability look like? I think so first, what are the large companies out there that really do deploy CCAs? There's Google that's designing CCAs, there's Netflix, Prime Video, there are these big companies. And I think maybe all of them to some extent favor things like throughput stability. Maybe as, Amazon's coming out with this cloud gaming, so they also probably care about latency. Google has video conferencing, they care about latency too. And I believe Netflix is also coming out with cloud gaming, so they should also have latency fairness. So I guess the question then is, given that everyone cares about latency fairness and everyone cares about throughput, we should most likely be able to converge on some deployability threshold that is in everyone's interest. No one wants an internet that is lossy, high latency, and luckily most large companies today have interests in both directions. So I think a deployability threshold that kind of takes industry stakeholders into the equation should be able to come up with something that's acceptable to everyone. And if it's acceptable to everyone, people will start using it to test deployability.
Okay, Ayush, I'll give you a chance to respond, but first let's have Ray ask her question.
Hello, I'm Ray from Carnegie Mellon. the Ray that Philip mentioned. Not everyone here knows who I am. I think like Philip said, well, the reason I came up is because we were talking about the fact that the issues with BBR were around fairness, but there was actually other issues that a lot of prior work was talking about before my model, that, for example, it had a lot of high retransmissions, and that was a big issue. So it's more than just like throughput fairness that we care about when we're talking about deploying a new algorithm. And I think there's something to be said there about like, should that be incorporated in a deployability threshold, right? Like Philip was saying, if I care about things like latency, how do I say this latency threshold, like what is that, right? I think that's a little bit more murky than just saying, you know, equal rate fairness, right? So it's just something to consider. But yeah, I think there were other issues with BBR that they also fixed with future versions of BBR other than just throughput fairness. Like there were other critiques that were also important. So, okay.
Okay, why don't both of you respond, and then we'll go to Marwan's question after that.
Okay, so I think I want to respond to this idea of a deployability metric where we sort of want to come up with a way where we have this congestion control algorithm and we want to figure out whether it's deployable or not. And for this, I think I'll come back to my initial point about these competing goals and different goals. And when you actually try to think of the deployability metric itself, it's actually a really hard thing to come up with because different people have different goals, different objective functions. So how are you ever going to compare this? What you're basically stuck with is coming up a way to compare apples with oranges. And I mean, what I'm proposing here is that let's just put them in separate baskets, and then we don't have this problem at all.
Cool. Marwan, you have a question?
I think, so maybe half question, half comment. It follows on a little bit of what a lot of people said, especially with what Ray just said. And I'm sorry to have to throw this out, but I'm going to anyway. Sometimes money ultimately is a big deal, and these things are inseparable. So as a case in point, if we talk about BBR and the packets that it drops, you can imagine as an operator, you're dropping 30% of packets that you transmit at your own edge device. And so now your choice is, do I switch my congestion control and fit in a whole bunch more connections? Do I provision additionally? Or if I'm not Netflix and I'm not Google and instead I'm an Akamai or maybe a cloud, who's paying me on the back end and what do they care about? So as much as I hate to say it, I think there are the economics in some form that have to play a role. And not so much as a how do we make sure the rich get richer, but maybe the like minimum level of something that everybody is entitled to. I don't know.
Yeah. Philip, why don't you respond?
Yeah, I do think that, well, yeah, first, I guess, yeah, to answer both their questions in our comments in one way is that I do think that there's no question that fairness is going to get more complicated as we have delay-sensitive and loss-sensitive applications. I do agree with Ayush that there is more work that needs to be done, and this work will be hard. Figuring out a threshold for deployability that takes all of these different factors into account is not easy. For example, even something as simple as latency, we can't just say, oh, you know, it's all latency is equal, because up to 50 milliseconds, for example, a lot of latency doesn't make a difference to cloud gaming or video conferencing. Beyond 200 milliseconds, there's a big difference. So I think there's plenty of potential future papers from folks here about maybe including user studies and things like that to understand what exactly is the utility function for each service. And then the question then is, how do you combine the utility functions for different services, right? The easy answer is to say, okay, let's just decide, okay, more than 50 milliseconds latency, bad. Less than X% of your fair share, bad. And then compare all services evenly. But if, for example, we find that certain people prefer certain kinds of services, like, maybe everyone wants to make sure their video conferencing goes well at no matter what, and they're willing to take a hit on their video streaming, maybe that's something a user study could figure out and plot this trade-off curve that people are kind of looking to make themselves, and we could have a differential fairness threshold depending on the.
So Philip, I think your response has been very sort of user-centric, right? Like, what do users want? But I think from what I understood of Marwan's question, his question was much more from the, like at me as someone who wants people to watch my videos, I don't care what the users want. I want people to watch my videos, right? Like, is there an argument that is this? Am I understanding your question
there's
correctly?
an element of like who's paying to put the bits on the wire, and I think we think of it typically as being the users. Certainly, I do. But the reality in a lot of cases is it's the providers, and those two things are not always going to be in equilibrium.
So just to clarify, was your question about the economic incentives that providers have to actually adhere to these fairness constraints? Or?
Yeah, so I think when we think about fairness, we think about individual receivers in a sense. Like, are they getting, but from an operator's perspective, they might be thinking, how many connections can I put on the wire? How can I reduce the latency on, like the median latency for everything? So it's a very different way of thinking on both ends and can be hard to reconcile.
Well, I guess thinking about it, I guess could you give me an example of where the two would diverge? I guess so. To me, it seems like if users everywhere get low latency, it also reduces the median latency for the provider. Is there a scenario?
So here's, maybe this is a contrived but simple example. Okay, so I'm transmitting a bunch of data, and I can fit K connections. With BBR, knowing that I'm dropping 30% of packets on the floor, but those flows that are on the wire are much lower latency than they would be otherwise. And I can afford to do this because whoever's paying me to put those bits on the wire is paying me more collectively than I would earn if I used a different congestion control and fit more connections on the bottleneck. Does that make sense?
Right. I guess to answer your question, I would have to say that these different properties are kind of interlinked. In the sense, for example, it's very hard to have high loss rate and low delay, for example, because most loss, I guess no one knows for a fact, but it's most likely because you're overflowing a bottleneck queue somewhere. And similarly, I think throughput fairness is also kind of linked to this, which is that if you want more throughput, you need to have a larger fraction of the queue occupancy, which means you're putting more packets in the queue, which means you're going to have higher latency. So I think in some ways, you don't have to trade off between between loss and latency for that specific example.
If I have one flow that is paying me $1 million per unit,
right,
versus 100,000 flows that each pay me $1.
I see. So you're saying some flows are more important than others, and you're willing to cause damage to these other flows for the sake of that.
Maybe not even cause damage, but ignore them completely and just not do it. I mean, this is I hope no operator does this type of thing, but it's impossible to ignore that there are aspects of this that exist on the network.
So yeah, why don't Philip, you respond quickly, but then I think we're running out of time.
Oh, sure.
So then I'll ask Ayush to give a closing statement, and we can sort of wrap up with you.
Sounds good. I guess I would definitely need to think about that a little more. I guess one thing that may be a bit of light in the scenario is that some of these aspects are shared. The loss rate you experience on a link is shared amongst all the different flows. The latency you experience on a link is shared amongst all the different flows. So improving this for that one important flow would also mean improving it for all of these other flows. So maybe that kind of makes the problem a little bit easier, but yeah, definitely, it's a question I should think more about. Thank you.
Great. Ayush, do you want to give a quick wrap-up closing statement?
Yeah, I mean, I can give a quick closing statement in favor of performance and isolation. Because I think I wanted to close this by giving an analogy for the modern internet. So I think of old congestion control algorithms on the old internet as, these old horse-drawn carts on cobble streets, right? Eventually, as the internet became more and more popular, we started running the risk of these carriages running each other off the road. So we invented speed limits, which is like fairness, to sort of allow everyone to still use the cobble streets in a safe way. But fast forward to today, and now we have these massive 10-lane freeways that not only have cars, but somehow we're also supporting bikes and locomotives on the same piece of tarmac.
I
right?
wouldn't want to bike on that freeway.
So I think in such a paradigm, it's probably valuable to first come up with bike lanes for our bikes and build a railroad for our locomotives, and then start to think about fairness, which is why I think fairness is definitely important. We still want the internet to be somewhat equitable, but I still think that isolation is more in line with how the internet is heterogeneous today in terms of both congestion control algorithms as well as the services and flows that it supports.
Cool. Thank you. Philip, do you want to wrap up, and then that'll be the end of our session?
Yeah. Just to conclude, I do agree that there are important points, and I think performance is important. And with this whole fairness question, there's the thing of how often is there contention, like Ayush hinted at, with the fact that we have freeways now. I think that's an important part of the debate, because basically, are you forcing people to get less performance in the common case if contention is the rare case, and you're optimizing for that? But that said, given the nature of fairness, in the sense that it's very hard to find out post facto. The best you will know about fairness is these deployment tests you do when you most likely write your paper for your CCA. I think it's important to double down on how thoroughly we test fairness there, and how much value we give to those fairness outcomes. Because otherwise, like we discussed, fairness is critical to the smooth functioning of the internet as a shared medium. It's very easy to end up in a race to the bottom. And I would advise caution, simply, I guess, as a metaphor, in the sense that, yes, my plane might fly, but I would definitely want to make sure it really can fly before I put it in the air. Thank you.
Great. So that's our debate. I think we don't have time for the other debate. So Keith and Banaz will be very happy that they don't have to come up on stage. I'm sure if you want to talk to them about machine learning and its applicability to networking, you can either think back to their discussion yesterday or find them for the rest of the conference. But thanks so much for agreeing to be in the debate, and thank you to all of you for attending.